Hello everyone watching this video. Welcome to today's presentation of the additional features of the Topology Renderer. My name is Tomáš Kovács and I am a member of the Inkston developer team. More information about the Inkston could be found on the webpage www.inkston.com. In this video I would like to introduce some new features of the Topology Renderer and some optimization we have done. The complete project we are going to play with is available on the link below. So let me clone the repository and open the solution. Generally speaking, it is not absolutely necessary to see the complete EtherCAT topology if there are no issues on the EtherCAT network. As for the complex topology, the generation process could be quite time-consuming. The topology generation process will start on demand when the topology renderer object becomes visible. In this example, we have 3 EtherCAT masters with different topologies. To be able to run the application without exactly the same hardware connected, we need to have all devices disabled. One core needs to be isolated when running this example inside the virtual machine. If you would like to run this example on the local machine, you need to change the number of cores according to your machine. Also, you need to change the AMSnet ID and AMS port to match your target. So let me load and start the PLC and start the application without debugging. As we have seen, the application started in a really short amount of time. Clicking on the Complete Topology tab from the menu, the generation process starts. As we could mention, it takes a while. Anyway, once it's generated, it is not necessary to generate it again, nor in case of leaving the tab. As we are running out of I/O, there are prepared some buttons to simulate the required states of the I/O. Let's open the Simulation tab and click on all 3 buttons in the first row. By doing this, all slaves of all 3 devices are going to be forced into the operational state. Let's move back to the Previous tab. All the terminals should change their colors and reach the OP state. Let's simulate now some abnormal behavior. Clicking on this last button, the unexpected link is going to be simulated on the last terminal in the topology. Let's move back to the Complete Topology tab. You can zoom in and out by holding the Control button plus the center mouse wheel, move up and down using the center mouse wheel, and move left and right by holding the Shift button plus the center mouse wheel. As we could notice, the problematic terminal was not immediately visible with the default zoom, and for an even larger topology it could be not so quickly localizable. Moreover, when a single touch screen is used for visualization without any mouse, it should be fine to have the possibility to handle it. That's why we added the GroupedView property to the Topology Renderer control. This allows us to view the group of EtherCAT slaves as one control and to evaluate the summary state of all included slaves. So let's open the tab User View Grouped. You can notice that the time of the generation is significantly shorter. As there are no issues on device 1 and device 2, let's click on device 3. A new window is opened and we could see that there is some issue with a group named Station 370. Let's click on the group view mentioned and the topology of the problematic group is displayed. Clicking on the terminal, the detailed view is displayed. So we have localized the problem with very few clicks without scrolling and without generating complete EtherCAT topology. The topology generation process was just partly triggered on the problematic segments. Let's now have a look at the implementation side. To generate the complete topology, it is only necessary to set the data context of the topology renderer to the complete global variable list. To display one EtherCAT device as a group, it is necessary to set the data context to that device, set the GroupedView property to true, and set the group name that is going to be displayed in the visualization. If there is no user view property specified, as in the case of the device 1, after clicking on the group view, new window is open with the complete topology of the device 1. Anyway, it is possible to define the own user control that is going to be used in the new window opened after clicking on the group view, as it is in the case of the devices 2 and 3. Let's have a look at the device 2. Let's divide it into the groups like this. So for the group Station 210, we need to set the data context to this first EtherCAT coupler. Anyway, in that case also these 2 couplers and their terminals became a part of this group. To filter them out, it is necessary to set the property exclude slave connected to junction box to true. The next two groups are pretty simple. We just need to set the data context to the EtherCAT coupler, and all terminals connected to it up to the last one is going to be included. To display these two couplers inside one group, we need to set the data context to this junction box, as it contains both couplers, as you could see in the device tree. To filter out the junction box itself from the view, we need to specify the first topology element property and set it to the name of this coupler. Also, the last topology element property should be defined if necessary. Moreover, to filter out this part, we need to set the property exclude slaves connected to junction box to true. Okay, so that was all from my side at the moment. If any detail was not clear, please feel free to write me an email at tomas.kovac@inkston.com.